Hey everyone, thanks so much for taking the time to hop on to our virtual senior design video to get a brief idea of our presentation and the work we've been doing this semester. My name is Jonathan DeLozier. I'm one of the team members from Team Nightmare at 60,000 feet, and I'm going to walk you through a bit of our project so you can hopefully get some more information. And then if you'd like to come see us at Expo, we'd love to see you there and give you more detailed information as well. Our team is composed of all aerospace engineering undergraduate students. We are taking the AE 4341 aircraft design class this semester, which was taught by Neil Weston and Carl Johnson. The rest of my team, who I'm representing today, are Cody, Chris, Josh, and Paul, and I'm super excited to walk you through the work we did together. To give you some background on our project, the motivation comes from a theoretical proposal put out by the United States Air Force that was given to us by our course instructors. The proposal itself is seeking a new aircraft to fill the long-range strike roles that were previously handled by the F-111 Aardvark and the F-117 Nighthawk aircraft. These aircraft had now been put into retirement by the Department of Defense and their affiliates, and so we're needing something new to fill that role. Though there is the B-21 Raider on the horizon that will provide stealth strike capabilities, the current estimated cost is around $80 billion for the first 100 units, and so the Air Force is looking for something cheaper that they can use to supplement the B-21 fleet in a higher volume and still have that stealth strike role. Therefore, we get to our objective of the project, which is to create a vehicle that will be unmanned, that does two big things. It removes pilot risk from the scenario, and it allows us to reduce cost. The vehicle also is going to exhibit low observability characteristics similar to the F-117, the B-21, B-2, the F-35, or many other fifth-generation aircraft. The vehicle will then also be able to deliver a specified payload of 4 Mark 83 JDAMs, those are 1,000-pound GPS-guided munitions, and it shall be able to deliver them from a range of 2,000 nautical miles. Finally, it will be able to fulfill any other performance requirements that are set forward by the request for proposal by the Air Force. To get into our design process for the project, this was something that went on iteratively throughout the entire semester. Beginning with our mission specifications, that was the request for proposal we were given by our instructors. We then went into what we considered our preliminary sizing process. This involved first looking at other aircraft that are of a similar classification and fulfill similar roles for the military, and then using that and the methods we discussed in class to get a general idea of our aircraft's takeoff weight, its empty weight, the fuel weight, other characteristics as well, such as the thrust at sea level, the actual planform area of the aircraft, general lift and drag characteristics, as well as some wing loading and thrust to weight ratio values. We then took that into a series of sensitivity studies where we really dug in and found how we could optimize those parameters to get the best aircraft possible. After we went back and forth, we had our initial preliminary design. We then took that and then fed that into part 2, which is where we really started digging into the layout of the system itself. This began with things such as propulsion system selection and propulsion system integration. It then dove into things like fuselage design, airfoil selection, wing design, getting into internal layout of fuel storage, the payload itself, weight and balance analysis, looking at the center of gravity of the various aircraft components. We then took that and we kept iterating on it more and more until we got a general configuration that we were happy with. We then refined that through lots of analysis, looking at things like we called Class 2 analysis, such as our weight and balance, our in-depth drag polar analysis using tools such as VSP Aero, also looking at stability and control derivatives to see if the aircraft would actually be stable and the flight conditions it would theoretically be put in to really verify our overall vehicle performance. From that point, we really solidified our design and then dove into things like the preliminary structural layout, landing gear design, and nailed the whole aircraft down together, finally coming together with cost estimations of our aircraft all the way from initial conceptual design through research, development, testing, first flight, and then production of 200 airframes. At the end of that, this was our result. We're proud to present the MB-22, which is our solution to the request for proposal we were given. This aircraft, we believe, will be able to not only handle the required flight characteristics and flight regimes required by the mission profile well, but it would also be able to exhibit the low observability characteristics and stealth characteristics we would like to see in the aircraft as well. It has range to meet the required 2,000 nautical mile payload drop, and it also has the capability to store larger bombs and potentially carry additional payload as well. Further, we find that this design would be much more economical than many options that have recently been put into the U.S. arsenal, such as the F-35, the F-22, or the B-21 bomber. Overall, we think this aircraft will be an incredible addition to the United States Air Force's fleet and would provide the exact role that was specified by the request given to us. Thanks again for taking the time to watch this video. I would love to meet you all in person if you get the chance to come by Expo and give you a real deep dive into our process and our results. And I hope you have a great day. Go Jackets!